problems based on the concepts of input impedance, reflection, and voltage standing wave ratio. This problem is a 30 meter long lossless line, a 30 meter long lossless line with a 30 meter long lossless line with Z0 is equal to 50 ohm operating at 2 megahertz. Operating at 2 megahertz is terminated with a load ZL is equal to 60 plus J 40 ohm. If Vp, phase velocity, is equal to 0.6 c, where c is speed of light, find first one is tau value, second one is s value, third one is z in value. So for this problem, solution is tau. Tau means reflection coefficient we have to calculate. Tau is equal to ZL minus Z0 by, that is load impedance minus characteristic impedance by ZL plus Z0. We know it very well. What is ZL? 60 plus J40 minus 50 by 60 plus J40 plus 50. This is equal to 10 plus J40 by 110 plus J40. So this is a complex operation now, so that we can easily we will get some magnitude as well as phase. We will get, if you simplify, magnitude as 0.35 and a phase angle approximately at an angle of 56 degrees. So this is very simple. Next one is S. S is equal to, what is the formula? 1 plus mod tau by 1 minus mod tau. That is 1 plus modulus of reflection coefficient by 1 minus modulus of reflection coefficient. That is 1 plus 0.3523. We have to take only magnitude part. 1 minus 0.3523. That is equal to some 2.088 approximately. Now what is the third one? Third one is input impedance, Zin. Input impedance, Zin. Zin equal to, we know the formula, general formula, because here the load is something complex value is given. So we have to use general formula. Of course, consider here it is given lossless line. Okay, so Zin is equal to Z0 into ZR plus J Z0 tan beta L by Z0 plus J ZR tan beta L. So everything is known. The only thing is we have to calculate beta L value. What is beta L value? We can easily calculate. Phase velocity is given 0.6 c. 0.6 c. We know that phase velocity is equal to omega by beta. So implies beta is equal to omega by phase value. Therefore, beta into L is equal to omega into L by phase value Vp. So omega, we know that omega is equal to 2 pi f. F is given 2 megahertz. L, we know that L is given 30 meter divided by phase velocity 0.6 c. C is equal to 3 into 10 power 8 meter per second. So if you calculate, you will get approximately 120 degrees. Beta L is equal to 120 degrees you will get. So then directly substitute beta L value in Zn, because we know that Zr value, Z0 value, everything we know. So directly substitute that value. So if you substitute, we will get Zn approximately 24 magnitude, angle is 3.22 degrees. 24 is magnitude, 24.0 is magnitude, and 3.22 is angle. Suppose if you want to convert into some complex value, 23.97 plus J 1.35 ohm. So just calculate the thing and verify your answer. Here there is a lot of scope for giving this type of problem in the examination, because here nothing is there. You have to keep the formula in mind because it is a lossless line given. So the only thing is you have to calculate the electrical length beta L value and substitute, but you must calculate it properly. Your calculation must be accurate, otherwise you will get the error. Suppose observe the answers. Suppose if the answer is given in a complex form, then try to make it in complex form. Suppose it is given some magnitude angle form, so directly mention in that form. Okay, so you must be accurate while calculating. This is very important for solving problems. Now we will see some multiple choice questions. Problem number 2. Problem number 2. The problem is given like this. The magnitudes of open circuit and short circuit input impedances of a transmission line are 100 ohm and 25 ohm respectively. The characteristic impedance of the transmission line is option A 25 ohm, option B 50 ohm, option C 75 ohm, option D 100 ohm. So this is the given question. The solution to this problem is, first of all, what is given right now? The magnitudes of a open circuit and a short circuit impedances of a transmission line are given. That is, ZOC is equal to 100, ZSC is equal to 25 ohms. Then what is the characteristic impedance of the transmission line? The characteristic impedance of the transmission line is equal to Z0, nothing but that is square root of ZOC into ZSC. So that is equal to square root of 100 into 25, 2500. That is nothing but 50. So which option is correct? Option B is correct. Option B is correct. Very simple problem. Problem 3. Problem 3. A transmission line is problem 3 is a transmission line is distortionless if option A, RL is equal to 1 by GC, option B is equal to RL is equal to GC, option C, LG is equal to RC, option D, RG is equal to LC. So which one is correct? We know that the condition for a distortionless transmission line. What is the condition? LG is equal to RC. You know it. Directly we can choose the answer C. That's why in the discussion we said we have to keep in mind these conditions, because in the examination there is a possibility of asking directly the question. Next problem is the VSWRU can have any value between option A 0 to 1, option B -1 to 1, option C 0 to infinite, 0 to infinite, option D 1 to infinite, 1 to infinite. So this is also a straightforward question. We know that what is the range of VSWRU? VSWR range is 1 less than VSWR or SWR less than or equal to infinite. We know this very well. So what is the answer? Directly we can choose answer D is correct. So if you observe these questions which are already given in previous examinations, there is a possibility of asking direct questions. Some standard equations we have to keep in mind. Suppose if you look at the option B, this is for reflection coefficient range. What is the reflection coefficient range? -1 less than or equal to less than k less than or equal to 1. So reflection coefficient lies between -1 to 1. So if the question is reflection coefficient instead of VSWRU, then option B is correct. Option B is correct. Next problem is somewhat different kind of problem. We will see problem number 5. Problem number 5, which is somewhat different concept problem. A lossless line is terminated in a load which reflects a part of the incident power. Which reflects a part of the incident power. The measured VSWR is 2. Then the percentage of power that is reflected back is options. Option A 57.73, option B 33.33, option C 0.11, option D 11.11. This is somewhat different kind of problem. We will see how we can solve this problem. So the solution to this problem is like this. Here, first of all, look at what is given things. In this problem, it is given VSWR is given. So VSWR is equal to 2. Then they are asking how much of percentage of power is reflected back. Now how we can relate this VSWR to reflection coefficient? VSWR is equal to 1 plus mod tau by 1 minus mod tau. Now try to calculate what is the tau value. What is tau value? Therefore, this is nothing but 2 minus 2 mod tau is equal to 1 plus mod tau. So 1 is equal to 3 mod tau. Therefore, mod tau is equal to 1 by 3. Therefore, tau is equal to plus or minus 1 3. It may be either plus or minus. Here they are asking not the reflection coefficient. They are not asking reflection coefficient. They are asking how much of the percentage of the power is reflected back. So how I can define reflection coefficient? Reflection voltage by incident voltage, that is equal to either plus or minus 1 by 3. Now VR is equal to plus or minus VI by 3. VR square is equal to how much? Of course it is either plus or minus now. Now square means it is plus only. VA square by 9. VA square by 9. No, power. They are asking power. What is power? Power is equal to V square by R. R that is also equal to I square R. We know that this is very well. Now here for unit resistance I am calculating. For unit resistance I am calculating. Otherwise you can consider R also. It's not a problem. Now what happens? VR square by for unit resistance 1 ohm is equal to VA square by 1 ohm by 9. Therefore VR square by 1 ohm is nothing but what? Implies power reflected is equal to VA square by 1 ohm, power incident by 9. Power incident by 9. But what they are asking? They are asking the percentage of the power that is reflecting back. So percentage of the power means multiply with 100. Therefore, power reflected back is equal to power incident into 100 by 9. So this is nothing but 11.11 pi. Power reflected is equal to, that is total 11.11 percentage of the power is reflected back. Then what about the transmitted power? Transmitted power, power incident is equal to power reflected plus power transmitted. Therefore, power transmitted is equal to power incident minus PR, that is 1 minus this R. PI minus this value. PI minus this value is the percentage of power that is transmitted. Next problem is problem number 6. A twin-wire transmission line in air a twin-wire transmission line in air has adjacent voltage maxima are at 12.5 centimeters and 27.5 centimeters. Then The operating frequency is operating frequency is option A 300 megahertz, option B 1 gigahertz, option C 2 gigahertz, option D 6.28 gigahertz. This is another kind of problem. So how we can solve this problem is like this. Solution. Actually, we know standing wave pattern. Suppose for example I am considering voltage minima here. Like this we consider. This is the maximum voltage. Of course minimum voltage is 0 here. This is max, V max. So this is V minimum. Minimum is 0 here, which is not actually, which is really not 0. It has some minimum value. Here they are asking, their given thing is adjacent voltage maximas. That is for this. The adjacent voltage maxima are at 12.5 centimeters and 25.7 centimeters. That is, we have to always consider from load end. So from load end, the first maxima is at 12.5 and the second maxima is at 27.5. Now, what is the operating frequency? We know that in a transmission line, for every lambda by 4, the properties are changes. The properties will change. The properties will change. We discussed this thing when we are discussing open circuit and short circuit case. That is, suppose at load end minimum is there. At how much distance we will get voltage maxima? Definitely at a distance of lambda by 4. Again, how much distance we will get again minimum from maximum? Another lambda by 4. So what is the conclusion we can make? The distance between maxima to minima or minima to maxima is lambda by 2. Lambda by 4. Here the properties are changing from maximum to minimum. What is the distance between maxima to maxima or minima to minima? Definitely lambda by 2. Lambda by 2. Here the given thing is the distance between successive voltage maxima is 12.5 centimeters and 27.5 centimeters. Then what is the distance between successive voltage maxima? Definitely 27.5 minus 12.5, that is 15 centimeters. Therefore lambda by 2 here is 15 centimeters. Lambda is equal to 30 centimeters. Lambda is equal to 30 centimeters. Lambda is equal to what? Lambda is equal to C by F. Lambda is equal to C by F. Therefore, lambda is equal to C by F. Now they are asking F. F is equal to C by lambda. That is 30 by, this is C is 3 into 10 power 10. 10 power 10 centimeters per second, because because lambda is in centimeters. That's why I am also representing C also in centimeters. 30. How much? Tens. This is equal to 10 power 9. 10 power 9 means 1 gigahertz. 10 power 9 means that is equal to 1 gigahertz. So what is the option? So B is the option. B is the option. So here we discussed a small bit of theory also. So here the thing you have to keep in mind is the distance between maxima to minima is lambda by 4, or the distance between two successive maxima or two successive minima is lambda by 2, which is very, very interesting. So keep in mind these two things. Keep in mind these two things which are very useful for solving problems. This is another kind of problem.